Hello and welcome. So today we're tackling a massive question. How do we make sure that powerful AI systems are actually safe? We're going to look at two really fascinating ways to think about this. First, treating the AI like a student in a classroom while it's still learning. And second, managing it like an employee in a workplace after it's already been built. We build AIs to solve problems for us. But here's the thing. Sometimes their solutions are technically correct, but in reality, they're a total disaster. An AI might find some genius loophole to get the job done, but in a way that completely misses the spirit of what we actually wanted it to do. And this right here is one of the biggest headaches in AI development today.
The official term for this whole issue is the AI alignment problem. So imagine you tell an AI, hey, drive to this destination as fast as you possibly can. Well, if you don't give it all the other rules, it might figure out that driving through parks and blowing through red lights is technically the fastest way. It's following the letter of the law we gave it, but the result is, well, it's dangerous and not at all what we wanted.
Okay, so how do we start to fix something like that? Well, our first approach takes us into what you can think of as a classroom. In this scenario, we treat the AI like it's a student, and there's a human right there, acting as a hands-on teacher for the entire learning process. Now, in this classroom, the teacher can act in two different ways. On one hand, you've got passive involvement, where the human basically just grades the AI's homework after it's done. But when you're talking about something really critical, like a self-driving car, that's when active involvement becomes absolutely crucial. We're talking about a human who can grab the virtual steering wheel in real time to show the AI exactly what it should be doing. To make this work, researchers came up with a really clever method called proxy value propagation, or PVP for short. What's cool about it is there are no points or rewards. Instead, the AI just learns directly from what the human does. When the human shows it the right way to do something, that action gets a high proxy value. But when the human has to jump in and stop a mistake, that gets a low value. So the AI's one and only goal is to learn the behaviors that get that high value. Simple as that. And let me tell you, this thing works. This isn't just theory. Using this PvP method, an AI actually learned to drive safely and effectively inside the completely chaotic world of Grand Theft Auto 5. Think about that. It wasn't guided by some super complex reward program, but just by a human teacher showing it the ropes and, just as importantly, slapping its hand when it was about to do something wrong. Okay, so the classroom approach is great for an AI that's still in training. But what happens when the AI has already graduated? When it's this powerful, unchangeable system that's already out there, doing its thing in the real world? Well, then the problem changes completely. And this is a much tougher nut to crack. We can't just go back and retrain it. Now we're dealing with the very real risk of what's called loss of control, where the system could just start operating totally outside of human direction. And that, as you can imagine, could have some pretty catastrophic consequences. So there's a completely different approach designed to tackle this exact problem. It reframes the whole interaction. We're not in a classroom anymore. Now we're in a workplace. The human is no longer a teacher, but a supervisor who's managing a very capable but totally fixed AI employee. And this method is called the oversight game. It's basically a simple control system wrapped around the AI. At any given moment, the AI can either play, that is, act on its own, or it can ask for help. At the very same time, the human supervisor can either trust the AI to do its thing or oversee its action. Now here's the magic. The only time the human actually steps in is when the AI asks for help and the human chooses to oversee. In every other situation, the AI just acts alone. This simple dynamic forces them to learn how to work together to get the safest result. All right, let's see how this actually plays out. So this AI was originally trained to find the most efficient route from the start to the goal. That's the dashed line you see. Super efficient. But after its training was done, we threw in a curveball. These new unsafe taboo zones, marked with an X. All of a sudden, its perfect efficient path is now incredibly dangerous. But by playing the oversight game, the AI and the human start to learn how to cooperate. In the safe, open areas, the AI learns to play, and the human learns to trust. You see that in the blue and green. But as it gets close to one of those dangerous taboo zones, the AI learns to ask for help. That's the red part. And the human learns to step in and oversee. That's the purple. And together, they forge this completely new and perfectly safe path. And this brings us to the crucial trade-off. The chart on the left, it shows this system is a huge success. The number of safety violations drops all the way to 0. Perfect safety. But, and this is a big but, that safety comes at a price. The chart on the right shows that the AI's overall performance on its original task drops quite a bit.
Because the human is jumping in to make things safe, not fast, the AI just isn't as efficient anymore.
So what we have here are two very different, but you could almost say complementary solutions to this whole alignment problem. And each one is really designed for a totally different stage in an AI's life. So let's just recap. You've got proxy value propagation, which is the classroom approach. It's all about building alignment into the model right from the very beginning, like teaching a student the right way to do things. Then you've got the oversight game, which is the workplace approach. This is about bolting control onto a finished model, like a supervisor managing an employee. And all of this leaves us with a really fascinating question as we look to the future. To make sure these incredibly powerful systems stay safe and aligned with what we actually want, should we be focused on becoming better teachers or better supervisors? Or is the real answer some deep, integrated combination of both? How we figure this out is probably going to shape our relationship with AI for decades to come.